Hello, I have a question for you. So let's say that I give you the matrix 4, 1, 3, and 2, and I ask you what is its inverse. How would you go about finding this? If I ask you to find what its inverse is, that means I'm asking you to find basically what this orange matrix is. It's when we take 4, 1, 3, 2, we multiply by an orange matrix, and we should be able to get the identity, or 1, 0, 0, 1. So how do we actually find this? Well, it may be hard for you to come up with this on your own, but there's actually a method that we can follow to find the inverse. Now, I'm first going to show you what the method is, and then later in this video, we're going to be trying to prove why this is true. So the method is fairly simple. All I have to do is I take my original matrix, 4, 1, 3, 2 right here, and then add on 1, 0, 0, 1 on the side, and I just take RREF. I can just plug this into my calculator or do this by hand and just do RREF until I get 1001 on the left hand side, and on the right hand side I'm left with these four numbers, and I claim that these four numbers are the inverse to 4132. So the matrix 2/5, -1/5, -3/5, and 4/5 is going to be the answer to our question, what is the inverse of 4132? Now, how do we prove this? Let's take a look. So first, notice that our method of construction involved this really funky looking thing at the top, and we're going to need that in our proof as well. So suppose that ABCD 1001, and if we apply REF, it's going to give us 1001 E, F, G, and H. Then we claim that if we are looking for the inverse of ABCD, that inverse is just going to be E, F, G, H. So we claim that E, F, G, H is the inverse of ABCD. Now, we need to prove this. So what's the proof of this? Well, let's take a look. So the proof is going to start off a little bit weird because, again, it's hard to come up with this on your own. But the idea is we're going to start off by taking our original matrix, and then we're going to multiply it by this x comma y matrix, this x comma y 2x1 matrix. And we can pick some, any, whatever x and y and just multiply it. That's allowed, right? Because we can just multiply it. And then once we multiply it, we're going to get a resulting matrix, and let's just call that matrix x prime and y prime. Now, if you're confused why you do this, you can hopefully continue watching through the video, or you can skip to a part where I have a big yellow star in the left-hand corner, and that's where I'm going to be trying to explain a little bit more of the context. But for now, let's try and continue with the algebra. So we're starting with this sort of algebraic setup, and now we want to analyze it. We want to break it down. What do we do with this? So the first step is we have a matrix multiplication up here, A, B, C, D, and X, Y. So I can multiply that out. And on the right-hand side, I can just write this as X prime, Y prime. So hopefully we can see how we can go between some matrices and an equation form. Now, for this equation form, I'm not going to change anything on the left-hand side. But on the right-hand side, I'm going to rewrite it in this slightly weirder way of 1x prime plus 0y prime, 0y prime plus 1x prime. And notice that these are exactly the same because this is 0, so I can just cross that out. That's 0, so this is just x prime, y prime. Oh shoot, I made a typo. So this should be, one second. This should be x prime and y prime. Great. So once again, if we cross out our zeros, then we're just left with x prime here and x prime here, which is correct, y prime here and y prime here, which is the same. So I'm just writing it in a slightly different way because now that I write it in this way, maybe we can turn it back into a matrix and see what happens. So the idea for this step is that, remember, we were given our supposition that we need to use this thing that we supposed earlier. And we want to find a matrix of the form ABCD 1001. And this is exactly what we have right here. If we write this into matrix form, we're going to get ABCD 1001. Now notice what the columns are. So the first column is column x, the second column is column y, this column is for x prime, and this column is for y prime. So this matrix here is just one way to represent our equations in a more concise way, in a matrix way. Now let's continue. Well, we got to use our supposition, right? So after we apply RREF, we get that, oh, this is the resulting matrix. 1, 0, 0, 1, E, F, G, and H. Okay, now we got to this point, but what do we do now? So the idea is now we want to unravel our steps, but on the other side, because here we were working with our variables all on the left-hand side, but now we have our variables on the right-hand side. So let's try and do something similar, but with E and F and G and H. So the first step is, let's turn it back into equation form. And if we turn it exactly back into equation form, you can see that my color coding, we have our x's and y's here, x's and y's here, and we have our x primes and y primes, and we're just going to get this, so these two equations in curly brackets. But once again, we can notice that, oh, how do I simplify this? Well, 0y is 0, and 0x is also 0. So the left-hand side, I can just simplify it into just an x and just a y. Otherwise, there's no change in between these two steps. And now, the next step of algebra is, okay, we simplified it, so now we can literally place square brackets around this and convert this back into a matrix form. So if we convert this back into a matrix form, we get xy equals, now we can split this into E, F, G, H times x prime, y prime. Now if you're confused on this step, try to just expand this out in your own time, and you'll realize EF times x prime, y prime, and then GH, x prime, y prime will give us exactly that. So now, okay, here is our final step of algebra. Let's bring it back to the beginning. So I'm going to draw my orange star right about here. So now that we've gone through all these algebraic steps, we end up at xy equals EFGH times x prime, y prime. But remember, in the very beginning, the very first step of our proof is that we supposed, or we took ABCD and we multiplied it by xy, and we set that equal to x prime, y prime. So notice that these two are actually very similar right now, and there's two ways to finish this question. One is algebraic, and one uses more conceptualized. Uses some more ideas that we're going to be focusing on more in the next few weeks. So the first thing is, let's try and do this with just simple algebra. So I'm going to keep it simple. You see this x prime, y prime? I'm just going to shade that in this highlight box, and I'm going to call this a yellow box. Oh shoot, maybe not the best idea to highlight. So let's color this in a yellow box right here. Bam, 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 bam. This is a yellow box. Now, do you know where else is a yellow box? Wow, this is also a yellow box, right? This x prime, y prime. It's the same down here and over here. So the idea is we're going to substitute this out. We know that this yellow box is equal to this, right? So we can take this and substitute it up here. Now see what happens. So let's first actually I'll just copy and paste this. So I'll take this, I'll copy it, and then I'll paste it. And let's move this down a little bit. Oh shoot. Let's see if we can paste it here. There we go. Let's paste it over here. So now what we want to do is, let's see. We want to substitute out this yellow box, and I'm just going to erase this right here, erase that. And when we substitute it out, what are we substituting it with? We're substituting it with A, B, C, D, A, B, C, D, and X, Y. So I'm going to write this as X, and then change colors, and Y. So what I did is, these terms, I just replaced it with here. So these two, if we look up here, I took this and I just replaced this term with the following. And now we get this equation. So notice that, okay, I'm going to do another box color. Notice that this purple box and this purple box are the same, right? So I can color them off as purple boxes. Okay, so purple box equals purple box. We know that, right? So that means that, does it make sense for me to say that everything inside here must be the identity? Because identity times purple box equals purple box. And so we have purple box equals identity times purple box. And that's why ABCD and EFGH must multiply together to be identity. And that's one of the algebraic ways to do it, through substitution. But now let's try and see if we can prove this and explain why we're doing this. Where did this come from? Now, this is a little bit more advanced because we're going to be dealing with this more in the next few units. But the idea is we can view x comma y as a point. Now, this is a little messy, so I'm going to scroll up. We can view this xy as a point. So what we're doing is we're taking a point and we're multiplying it by our matrix. And what do we get? We get another point. So that means that we can kind of view, let's see, this matrix right here, we can view this matrix as some sort of transformation or a function that takes a point, x comma y, and it transforms or outputs a new point, x prime, y prime. So that means that if I take my original point, x comma y, I'm going to shift up a tiny bit. If I take my original point, x comma y, and I multiply by my matrix ABCD, I'm going to get a new point, x prime comma y prime, and this sort of matrix sends xy to this point. So now, if we scroll all the way down, what we got here is that xy equals EFGH times x prime y prime. So I'm going to rewrite this up here. We had another expression where xy equals EFGH times x prime y prime. Well, what does this mean? So I'm going to, let's call this matrix purple. So if we take our red point, we're starting from a red point, and we multiply it by our purple matrix, we're going to end up with xy. So if I start from my red point right here, and I go with the purple matrix, I come back to xy, because I take this x prime comma y prime, I multiply it, and I get it to be equal to xy. So what happens if we start from xy, and then we multiply by our orange matrix, which sends the point by this orange arrow, and then I multiply by EFGH, which sends it back by the purple arrow. So I took a step forward, and then I took a step back, which means I didn't move at all. So that's sort of why EFGH and ABCD are inverses, because they undo each other's actions. The purple arrow and the orange arrow, they undo each other. And that's also what the idea of this proof is we try to consider, okay, what happens, what does matrix ABCD do to the point x comma y? Oh, it turns it into x prime y prime. Now how do we turn it back? How do we turn it back into xy? And that's basically the idea of this question. And it was mostly just algebra. So if we go through the algebraic steps, we can prove, we can find exactly that we can end up with EFGH, ABC multiplied together is going to give us the identity. So all of this is just to say, how do we find the inverse of 4, 1, 3, 2? We just take the RREF, and everything in this red little box is our matrix. So this method is actually very easy, but the proof is a little bit harder.